hope you are doing fine at home. We want to continue with our revision class, and in today's lesson we're going to be looking at two topics, which are approximation and estimation. Then the second topic is calculations involving standard form. You have done all these things probably in your JSS3 or JSS2, but we need to revisit it as you prepare for external examination. The objective is you should be able to recall the steps in approximation and estimation, then apply these steps in solving question, in past question. Then the third one is you should be able to recall the step in calculation involving standard form, and at the same time apply them in solving past question. Now let's have the example on approximating numbers. The question here says round up 216.82543 to Roman figure 1, 2 decimal places. Anytime you see DP, it represents decimal places. So we now say solution to question 1, 216.8254 to 2 decimal places. 2 decimal places simply means after the set decimal, count 2 numbers. And let us count together. We have 216 point. The first number is 8. The second number is 2. But just before we stop, we consider the next number. And in this case now, what is the next number? The next number is 5, which is higher than 4. In this case, we round it up. But when it is less than 5, we round it off. So we are rounding up 5 to 1, adding it to 2, and that will give us what? 83. That means we have 216.8254 is equal to 216.83 to 2 places of decimal. And in the second example, we have the same number to nearest 100. Nearest 100. Nearest 100 simply means there must be 2 zeros at the last part of the figure. If it is nearest tens, you are ending it with at least a 0. If it is nearest 1,000, you are ending it with 3 zeros. So in this case, you are ending it with to the nearest 100. So we have this one to be, if this is going to be nearest 100, then the decimal part will be forgotten. We are only considering the whole number part. So the 2 numbers here now, we are changing it to zeros. The last 2 numbers before the decimal part, we are changing it to 0, and this will make us to have 2. But just before we write this 2, we consider this number before 2. Are we rounding it off or we are rounding it up? It's less than 5, so it has to be rounded off, which is 0. So we have it to be 200. It has to be 0.00, but 200.00 is also the same as 200. So to the nearest 100, we have it to be 200. The third question we have to 2 SF. SF means significant figure. We have 216.8254 to 2 SF. 2 significant figure. That means we need the 2 most significant number in all these numbers written there. And I want to tell you, the most significant number is this. The next to that, the next to that, the next to that, next, up to this. So we need the 2 most significant figure, which are 2 and 1. So we should have 2. But before we pick the last one, which is 1, we consider this number. Are we rounding it off or we are rounding it up? You agree with me that it's more than 4. So we have to round it up to 1. Adding that 1 to this, that will make it to have 2. These are the 2 most significant figures. But at the end, we round up this one to 0. So every other thing turns to 0, we have this one to be 0.0000. And of course, there's nothing like this. We should have it as 220. So 216.8254 to 2 significant figure is 220. Okay, and the last one there is talking about to the nearest whole number. Whole number means there must not be decimal. You forget the decimal part of it. So we have 216.8254 to whole number, nearest whole number. This will give us the whole number we have here is this. But just after the decimal, we have the number 8, which we have to round up because it is higher than 4. So of course, when we have round up this one to 1, adding it to 216, it gives us 217. So our final answer in this case becomes 217 as the value to the nearest whole number. Okay. Calculating the standard form. This one, you are so familiar with this one. A number is said to be in standard form if it is written in the form a times 10 raised to the power n, where a is a number between 1 and 10. It's not up to 10, but it's more than 1. 1 or 9.9999. And our n is an integer. So in this case now, if we are solving this one without wasting our time, if we are to put the decimal point to make this number be between 1 and 10, if we place the decimal point here, this is 856, which is more than 10. The best place to put the decimal is to put it at the front of 8 to make the number less than 10. So once the number is less than 10 now, we have 856. All the zeros after decimal, they are rendered useless. So we now say times 10. How many times did we shift the decimal? The decimal is at the last part. How many times did we shift it to the front of the first number? We move 1, 2, 3, 4, 5. And this one becomes 8.56 times 10 raised to the power 5. And looking at the second example here, it's almost similar to this. But in this case, the decimal, we have some zeros before the first significant figure. So we just go from what I told you. Your number must always be between 1 and 10. So to make this number be between 1 and 10, the decimal has to be shifted here. So shifting it there, we have 7.6 times 10. How many times do we shift the decimal? 1, 2, 3. But when we are shifting from the left to the right, we have negative. But when we are moving from the right to the left, we have positive. So in this case, we have 1, 2, 3, which will give us negative 3. I think that is understood. And in our last example, how do you evaluate this? You are adding this. But before you add, look at the power of 10. The power of 10 here is 4, while the power of 10 here is 5. You have to make them equal. How then do you make them equal? You consider the smaller power. Make sure you increase it to be equal to the higher power. So in this case now, our 3.6 times 10 raised to the power 4, that was carrying the smaller power now. If we are making it to be equal to 5, we are shifting this decimal point here, and we are adding plus 1 to it. That means the same number will now give us 0.36 times 10 raised to the power 5. I think you got that. We have made them equal. You can now go ahead with your normal addition, which will give you 5.7 times 10 raised to the power 5 plus 0.36 times 10 raised to the power 5. And of course, this is the same as 0. This is 6. 7 plus 3, 10. Keep 1. 5 plus this one, that will give us 6. So we add the answer to the 6.06 times 10 raised to the power what? 5. I think you must have learned something in today's lesson. We are going to be sending the other examples to you via the Google Notes. So have a nice day. See you next week. Bye.